Welcome to this series of operations management. In this series, we are today talking about the capacity planning and capacity management. So in the last series, we had talked about capacity planning for short-term basis. So we had talked about in short term, you can increase the inventory, you can hire or lay off employees, you can use overtime, you can train your employees for multi-skilled, you can redesign your job, you can give the jobs on subcontracting, you can have proper maintenance systems, you can remove bottlenecks in your production line, you can balance your line so that you are able to utilize your capacity. So those are some short-term ways. Today we will be talking about long-term capacity modification. What are the long-term? So for example, in long-term is say 3 years from now, more than 2 or 3 years from now, you want to plan for the capacity planning, for the capacity modification, capacity management of your plant or your business. So what are the alternatives? So we can say there is an alternative of capacity cushioning, capacity timing, economy of scale. So what is capacity cushioning? Capacity cushioning is that you take up extra capacity in your plant so that in case of any volatility, any fluctuation in demand in the market, any variability of demand in the market, you are able to meet that demand, because you at any point of time you are having some excess capacity with you. Then capacity timing is also very important. Capacity timing, is your system flexible enough to adapt to the increasing demand? Similarly, is your system adaptable to meet the demand for a different kind of product, slightly different kind of product? So your capacity is able to adjust to that or not. So that is also very important. Then, as in our last series we had talked that capacity timing is also important, because if suppose your forecasting says that in the near term the capacity is going to increase in the next 6 months, so whether you are able to increase your capacity for the next 6 months. If you take more time and the demand is met by your competitors, then there is no use of increasing the capacity, because the first mover advantage is taken by your competitors. And then economy of scale is also very important. We will be seeing in further that why economy of scale is very important. Sometimes if you have a larger scale, if you are producing at a larger scale, definitely your cost per unit increases. But if your scale gets higher and higher, sometimes the cost may increase after some times. So what is capacity cushion? Let us see from this slide also. The amount of reserve capacity that a firm maintains to handle sudden increases in demand is called capacity cushion. So there is a formula of also 100 minus utilization rate is called the capacity cushion. So a large capacity cushion is necessary if the demand is uncertain or if absenteeism is high in your plant. But what are the limitations? It may lead to unused capacity cost and hidden inefficiencies. So capacity cushion is just like excess capacity in your plant, wherein if the demand is high, yes, all of a sudden the demand becomes high, you are able to meet it. But if the demand does not increases, then your capacity of your plant is unused, so it will lead to less efficiency. So similarly, timing of expansion is also very important. So there are various strategies. There is an expansionist strategy. If there are large infrequent jumps in capacity, then this strategy is right. But if there are smaller, more frequent jumps are there, then wait and see strategy may be the right strategy. If there is another strategy called follow the leader strategy. So here you can expand when the others are expanding, when your competitors or when the leaders are expanding. So that is the timing of expansion, as I have been talking in the last series also, is very important. So you have to develop flexibility into your systems. You have to take the life cycle of your product also in your account. So as you have studied product life cycle, the product life cycle is introduction stage, There is a growth stage, there is a maturity stage, and there is a decline stage. Take a big picture approach to capacity changes. Prepare to deal with capacity chunks. Attempt to smooth out capacity requirements. Identify the optimal operating level. So you have to design flexibility in your system, because if your product is already in the decline stage and you are deciding to expand the capacity of a plant, it will be of no use. So you have to see whether your product is in the introduction stage. If it is in the growth stage, then yes, it makes sense to increase the capacity of a plant. But if it is already reached maturity stage, you have to know at what level of maturity stage it is. And definitely, so you may have the wait and see strategy, you may have follow the leader strategy, you may have the balanced approach strategy, and definitely, but if it is in the decline stage, definitely there has to be a contracting stage strategy over there. So you have to have the big picture approach. You have to deal with capacity chunks. Capacity chunks means all of a sudden the demand increases. So how do you handle that? So for that, if it may be a temporary rise in the demand, so for that you are not going to invest a huge amount in increasing your capacity. So here you have to again see the short term capacity strategy. You may have to follow, you may have to outsource, you may have to convert from 1 shift to 2 shifts, or from 2 shifts to 3 shifts. You may have to give overtime to your people. So you have to ensure that the capacity is able to smooth out any demand variability in the system. Now let us see a very important term called economies of scale. So what is economies of scale? If the output rate is less than the optimal level, increasing output rate results in decreasing average unit costs. And what is diseconomies of scale? It means if the output rate is more than the optimum level, increasing the output rate results in increasing average unit cost. So economies of scale means that if you have a bigger plant, in that case your variable cost reduces, so your total average cost reduce. But diseconomies of scale means that there is an optimal level if you are producing much more than the capacity of your plant, because it may result in inefficiencies, it may result in diseconomies of scale. Let us see this figure on the slide. So production units have an optimal rate of output for minimal cost. So here on x-axis we are showing the rate of output, and on y-axis we are trying to show you the cost. So as the volume is increasing on x-axis, as you are producing more number of units, your cost is decreasing. So there is a arc over there. So this arc is showing, so at lower volume of output the cost is more, but slowly the cost is reducing, and after that the cost becomes constant. It does not keep on reducing. At one point, some point it becomes constant, so that point is the minimum cost, and after that at some point it also start increasing. So that point where you are getting the minimum cost is the optimal point. So that is the economy of scale. Let us see this slide also. So here we are showing 3 arcs over there. So there is a small plant, there is a medium plant, and there is a large plant. So if you see the minimum cost for a small plant, there is a horizontal line. Then for a medium plant, the cost is low, because that means if you are increasing the scale, the overall cost to produce per unit is reducing. And then further, if you increase the scale of your plant, there is a large plant, further the cost is reducing. But in each plant, small plant, at some optimal point the cost again starts increasing. Similarly, in the medium plant also the cost starts increasing, and in the large plant also cost starts increasing. What is the reason for that? why the cost is increasing after a certain point of time. So why the cost is increasing after a certain point of time? See, when I'll just draw an analogy from our day-to-day lives to make it very simple. Let us say you have a kitchen in your homes, you are making food for that. So your kitchen may be designed to make food for some set number of people in a family. Let's say 5 people, 6, 7. So you can make food for, sometimes there are guests in your family, you can make food for 10 people, 10, 12 people. But the kitchen is, or your utensils, your cookers, your other utensils are designed to produce food for 6, 7 people. Sometimes you may produce goods for say 10 people, 12 people, there are guests in the family. But let's say if there are guests, 50 guests in your family, will it be able to handle? Do you think the cost will be low? The cost will be more, because at one point of time you will not be able to produce food for 50 people in your home kitchen. You will have to hire some more utensils, you will have to hire some more people to cook. Maybe the house members may not be able to make that. So you will have to spend extra on that. And your utensils will not be, so if you are making a particular dish, you have to make it two times, 3 times. So you want bigger utensils. So for that you will have to hire. So you have to increase the scale to reduce your cost. So in order to produce food for 50 people in a home kitchen, the cost will increase. But yes, if you are producing food for 2 people, 5 people can also eat many times in the same. So your cost per person will reduce. So this analogy you can apply in economies of scale. So let us now see how do you plan to increase your service capacity. So we have to take both the sectors, the manufacturing sectors as well as the service sector. So if you let's say it is a service industry, let's say it's a bank, or if it is a restaurant, if it is a college, these are service industries. So you need to be near customers to utilize your full capacity. So here capacity and location are closely tied. In the service industry, the characteristic is inability to store services. So capacity must be matched with timing of demand, degree of volatility of demand, so peak demand periods you have to see. So in a service industry, basically it cannot be inventories. In a manufacturing industry, you have manufactured some goods, today the demand is not there, so you have made the stock. For example, in winters, the industries can produce fans, they can produce air conditioner, they can produce coolers, so that they are able to meet the peak demand in this season, so they can store the products. But in a service industry, you cannot store. You have a theater with a capacity of say 500 people, but on a particular day your seats, just 100 seats are full, so you cannot store it to be used in the next show. In the next show the capacity does not become 500 plus 400, it will remain 500 only. So those are the challenges in a service industry for capacity. So it is, so there are various other strategies in a service sector to utilize your full capacity. Now there are cost volume relationships also. In our earlier series we have been talking about break-even points. So break-even point is very important here in capacity utilization also. So here in this slide you see on the x-axis there is the volume of units being produced, and the y-axis again shows the cost. So there is a horizontal line which is showing you the fixed cost. In a particular setup there is a fixed cost, irrespective of whether you are producing 0 units or you are producing more units, you have to incur that fixed cost. That fixed cost is on, maybe on rent, it may be the interest on your loan, it may be the salaries, it may be the electricity expenses which you are producing, which your administrative cost which is fixed. Then there is a line showing total variable cost. So there are some costs which are variable cost. For example, in a restaurant, the number of dishes you make, the more raw materials you are using, so that is variable cost are increasing. If you are not, if you are having 0 order, your raw material cost on the food items is 0. But as you are producing more, your variable costs are increasing. And then your total cost is the total of fixed cost plus the variable cost. So it starts from the point your fixed costs are starting. So that is your total cost. So in capacity planning, you have to understand that this is the characteristic of our cost. So once again, if we see, in this slide, so there is a total cost and we are showing the total variable cost over here. So if we see now this slide, so if suppose you have got one machine, this is the characteristic of your total cost. When you have say 2 machines or 2 plants or 2 equipments, then your total costs are increasing, and if you have 3 machines or 3 plants, then again your total costs are increasing. So you have to understand that because your overall fixed cost is increasing. So that is why your total costs are increasing. So it is known as step fixed cost. So one has to evaluate them financially also, all these fixed costs. So your break-even point, for example, if you have 2 machines, your break-even point is at 1 point, and if you have 3 machines, your break-even point increases. So you will have to produce more, or you will have to sell more in order to achieve break-even. So therefore, one has to see all these things, that what is my break-even point, whether I should increase the capacity by buying more machines, or so there is another very important thing in capacity planning, whether there are some products which, for example, a company is making a final product. So should they make all the components of that product themselves, or some of the products they can buy? For example, an automobile manufacturer, let's say it's making a car. So does it produce all the parts which are used in the car? Not necessarily. It produces some parts themselves, some parts are bought from outside, because it may not be feasible to expand your capacity so much that you are producing each and every part. For example, a car manufacturer may not be manufacturing the carburetor themselves, they may not be manufacturing the spark plug themselves, they may not be manufacturing the lights themselves, they may not be manufacturing the leather seats themselves. So some of the items they buy from others. So make or buy is also a very important decision to be taken in capacity management. So you have to look for what is my available capacity, what is my expertise in that product, in that component, what is the quality considerations which are required, what is the nature of the demand, and what is the cost overall, and what is the risk in producing that. So for example, again I give you a very simple example from your homes. Let's say you are an expert in making a North Indian food in your home, but you are not an expert in making South Indian food. You do not know how to make the sambar, you do not know how to make the chutney and all. So if you make it in your home, it will be more costlier for you, because and you will take more time, and it will be risky also. If the taste is not according to the desired quality, then you may waste all the materials. So it becomes prudent to buy that particular food from outside. So it will be more cheaper to go to a restaurant than to make it yourself. So similarly in industries also, there are certain components for which the expertise is not there, your capacity is not there, you cannot meet the quality requirements, you do not have the domain knowledge of that particular product. So it's better to buy those products from outside rather than increasing your capacity for that. So many times you have to see all these things. Let us take one numerical problem. So this numerical problem says a fabrication unit of an organization should supply 5,000 parts to another department assembly in 1 day of 24 hours, and the processing time is 4 minutes per unit, and the machine efficiency for 3 shifts daily is estimated at 80%. Calculate the number of machines requirement of the department. So this is a very simple example of capacity planning. So you have to decide how many machines I should have. This is my requirement. So how do we solve this problem? So let us see. First we will calculate total time in minutes required to fabricate 5,000 parts to another department assembly in 1 day of 24 hours. How much time I will take? So since processing time is 4 minutes per unit, which is given in our question, and total time to produce 5,000 units will be, because one unit takes 4 minutes, so how much time 5,000 units will take? 5,000 into 4 is, it will take 20,000 minutes, and you have to produce in it 1 day of 24 hours. But in 1 day, how much time you do have? One work shift is of 8 hours and 1 hour is of 60 minutes. So 1 day consists of 8 hours multiplied by 3 shifts of 8 hours each multiplied by 60 minutes. So 1 day consists of 1440 minutes, 1440 minutes. So since the machine efficiency for 3 shifts daily is estimated at 80%, so you're not able to achieve, because there is a lunch time also, there are breaks also, there is a maintenance time also. So you multiply 1440 by 80%, so you get only 1152 minutes. But your requirement is, number of machines required is, but your requirement is 20,000 minutes. But your available time is 1152 minutes. So you will divide 20,000 minutes by 1152 minutes. So you get 17.3611. So that means you need 18 machines for your plant, which will be able to meet the desired requirement. So this is how you solve these problems. So this is how we solve, in actual life also, the capacity, what is the capacity required. So based on the demand, based on the requirement, availability of the minutes in a particular 1 shift or 2 shift or 3 shifts, and what is the requirement, how much time is the processing time taken for each part. So here you have calculated that 18 machines are required. We will see one more numerical problem so as to understand it comprehensively. So numerical problem 2. This is a little difficult problem than the first one. So here we are saying a product is manufactured in a shop using a 5-stage process. The first step in the process is to cut the sheet metal to required shapes and sizes using a shearing process. And after the shearing process, the components are subjected to pressing operations to alter the shape of the flat sheet as per the design. In the third stage of the process, welding is done to join the components. And then the next step in the process is the painting operation. After painting, the components are sent for packing and kept ready for dispatch. The time taken for each of these operations is 20, 30, 15, 12 and 6 minutes respectively. Presently, each stage has only one machine for operation. So what is the question? What we have to calculate? So the question says you have to map the process and analyze the capacity with respect to the following scenarios. Number 1, if the shop works on an 8-hour shift with an effective available time of 450 minutes, what is the production capacity of the shop? We have to calculate the production capacity of the shop. The second part of the question is, what is the bottleneck in the system? If we want to add one more machine, where should we make the investment? And the third part of the question says, identify the additional capacity required for a daily production target of 25 units and compute the utilization of the machines as per the revised capacity calculations. So this is a typical question wherein we have to calculate. So for example, first of all, if we see this chart, there are processes. So the first process is the shearing process. So here in the question it says the processing time taken is 20 minutes, pressing time takes 30 minutes, welding takes 15 minutes, painting takes 12 minutes and packing takes 8 minutes. But the time available per day in terms of minutes in an 8-hour shift is 450 minutes in each of them. So what is the output? So output efficiency is basically 20 divided by 450 that is 22% utilization, you can say, uh, and 30 divided by 450, 15 divided by 450 into 100, 12 divided by 450. So basically we have seen that here, you know, the 15 minutes is taken by pressing the output. The output produced by pressing is 15. So the bottleneck operation is pressing, because the minimum time which an operation is taking, that is the bottleneck operation. So investment should be made to add another pressing machine. So this will result in effective pressing time of 15 minutes per unit instead of 30 minutes per unit. So production target, if the production target is 25 per day and the maximum time allowed for each stage will be 450 upon 25, so that is equal to 18 minutes. So the solution is to have 2 pressing machines in parallel and 2 shearing machines in parallel. So the utilization formula is actual output upon design capacity, or we can say daily production into process time divided by number of machines into available time. So if we see the chart, we will see the utilization of each of these machines. So here the utilization of shearing is 55%, 83%, etc. So this is how we calculate all these things. So overall, from this numerical problem and from this session, what we have understood is that we have to know where is the bottleneck operation. So the bottleneck operation is that part which is taking the minimum time, which is able to produce the minimum number of units. So even if you produce more units at the previous stage, it will be futile, because it will have a lot of waiting time for that. So you have to balance your machines by having more capacity of that operation, and internally you can increase your capacity like that. But if overall for the long term, if there is more demand, you have to take call that whether to install more machines, whether to set up another plant, etc. So capacity planning is very necessary, very important, because if excess capacity is there, then the actual demand, then you are incurring more cost, your break-even point will be very high. But if your capacity is very short than the actual demand, then you are not able to meet the requirement, and you will be missing the profits which you could have earned. So I hope that this session would be useful to you, and this session will set the course for other topics in operations management. Thank you.